Hello, everyone. Thank you, Nick, for that nice welcome. My name is Phan. I'm part of the technical product marketing team here at HashiCorp. And as you saw, Kareem took you through the infrastructure lifecycle management of the infrastructure cloud. So I'm going to take you through the second half, which is the security lifecycle management of the infrastructure cloud. And specifically, we'll focus in on Vault and Boundary to help reduce your overall risk. So let's kind of take a step back and set the context a bit. So we sent out a survey last year to a bunch of organizations and a bunch of different cloud leaders and asked them, what is your number one concern? What is your biggest concern when it comes to cloud security? And the respondents came back and said that their number one concern was having their credentials and secrets being exposed or leaked outside of their organization. And this concern was higher than having data theft or having phishing or social engineering attacks. So this was quite interesting, but it's also really validated as well because also last year, Verizon came out with a report that stated 9 out of 10 web application breaches were due to stolen credentials. That was quite jarring. Also, in the last 2 years, there's a 4x increase in data breaches. And 3 out of 4 of those breaches had some sort of human element that was involved. So really interesting numbers, especially the 9 out of 10 part. That was, I found interesting. And so, we want to take a look at how we can help organizations reduce their overall risk when it comes down to protecting credentials and when it comes down to protecting the resources and applications that those credentials are being used for. And from our point of view, it's not just a couple of features that secure a couple of things here and there. It's more of a holistic approach to security lifecycle management of your credentials, security lifecycle management of your resources and applications. And the reason for that is because, as we all know, you deploy applications on day 0, day 1, and really that's not the end of it, right? You're continuing to protect those applications over time on day 2, day 3, all the way till day N when you actually are retiring those applications. So from our standpoint, we have the HashiCorp Cloud Platform that includes a suite of tools to help with this. As you guys all probably already know, we have Vault for identity-based secrets management. We have Boundary for modern PAM, modern privileged access management. And we have Consul for identity-based network security using Consul service mesh. Right? And so really with these tools, we want organizations to be able to have the systems in place to really protect their state, inspect their data sources for credential vulnerabilities, and also help connect users and systems to other infrastructure resources and applications. So let's kind of get into it a little bit more. So I wanted to take a look at and see how we can use Vault and Boundary to really, really reduce that overall risk. And we'll take an example of an organization that starts off, in one place where they're very immature in terms of protecting credentials. They have a lot of unmanaged credentials and all over the place. And then how they can then migrate and move on with their journey to being more mature and leveraging Vault and bringing everything under a single management platform. Then we'll look at how we can further reduce that risk by leveraging dynamic secrets. And then we'll tie that all up in a bow and bring in Boundary to help streamline the workflow for end users who consume and use those credentials in order to access the resources inside your infrastructure, right? So we'll start with the initial challenge that many organizations, if not all, face where they have credentials that are sprawled all over the place, like Confluence and various types of repos. And the reason for this is they have developers within the organization that a lot of times store secrets and credentials and keys in various locations, including directly in their code, in wikis, in repos. And inevitably, these secrets are no longer secret because they end up sharing it with other teammates, with other teams. They make their repo public, so now it's out in the open. Or the developer has copies of that at home or multiple copies of that online, and they end up leaving the company. So you're now exposed, whether you're done on purpose or not, right? So now you have that challenge of sprawled credentials everywhere, you're exposed. So it's really hard for security folks to really get a handle when you don't know where these credentials are located. And a lot of times these credentials are long-lived as well. So if they're long-lived, coupled by the fact that it's being shared, it really increases that risk and affects the security posture of your organization. So, whoops. So what do you do about that, right? Well, I had to go back there. The first step is really about discovery, finding out where these credentials are located, finding out what your blast radius is, right? It's not a matter of if you have these credentials in unmanaged locations. It's a matter of how many do you have and where are they located. Only when you get them under a single platform, under single management, that's when you can apply best practices and policies and really control that from going out into the open again, right? So next question is, how do you discover these? Well, we have something called HCP Vault Radar, and really this is a tool to help organizations to get a really comprehensive assessment of what their current vulnerabilities are when it comes to credentials, and it helps locate all of your credentials and then find remediation steps. So it really comes in a couple of steps here. It's really straightforward. The first step is obviously detection, right? HCP Vault Radar has the ability to go detect up to 18 different data sources. We just added 2 more, as you saw from Armand's keynote. We had 2 more data sources, and we're going to continue building upon that as we go along. It has the ability to detect over 300 secrets patterns. So, you can detect all different type of secrets. It does post-processing steps as well to ensure that there's high accuracy and there's no false positives. So once you have that detection, then you move on to the inventory or the cataloging phase where HCP Vault Radar provides context of these different credentials that were detected. What the severity of these credentials are, what type of credential it is, who the author is, what the source is, what are the recommendations on remediation. And then at that point, you work with your existing workflows to triage the detection and pass it on to the owners of those data sources or of those credentials to remediate, right? So that's HCP Vault Radar. And now as we talked about the whole kind of journey, you went from unmanaged to detection, and now, how do you prevent yourself from actually going back to that place, right? You have plans for remediation, but you don't want to regress back to where you were. So HCP Vault Radar has various integration points that works with your developers and operations teams to integrate with existing tools that are very, very familiar. So that's not just about detection, but it's about notification in real time as well. It's about integrating with ticketing systems and tracking systems. So for example, you have integration with Slack. So if there's a detection in real time, you'll get a Slack notification, at which point you can then dig in and understand what it is. There's integration with things like GitHub or Bitbucket where it can prevent credentials from even going out in the first place. So if there was a PR request and that would trigger a scan, and then if there's a credential that was stored and detected, it would prevent the merge until remediation takes place, right? So there's other integration with things like ServiceNow to create tickets and be able to track these detections and ensure that you're not just notified, but you're also tracking it and ensuring that it comes to a close and remediated. All right, so now that we've detected, we have a standardized way to use or to not go back to where we were, and you have a plan to remediate. Part of the remediation is obviously removing them from those unmanaged credentials, unmanaged locations. But then the other part of remediation is, where is that place where you want to provide your developers with places to store the credentials? So ideally, you'd have something like HCP Vault, which is an industry-leading industry-leading secrets management platform that has lots of really advanced capabilities with all sorts of different secrets engines to store and generate credentials. And one of the simplest secrets engine and most commonly used is the KV secrets engine, where you can go in and store static credentials. So you grab the credentials from those unmanaged locations, delete those, bring them into Vault. So now you have a centralized place where you're consolidating all those static credentials and you're managing them there. You're applying policy, governance, audit logs, best practices, and better control over your credentials for your organization. You can apply permissions for certain users and certain teams to access very specific credentials. And so you have a lot more control, like I mentioned. So that's great. You're slowly maturing into leveraging a standardized tool for this. What is the remaining challenge still? As you're using KV, the KV engine for static credentials, these credentials are still static, right? So that's not ideal. Static credentials are fine if you're on top of things and you're constantly rotating them to make sure that they are short-lived, but of course that adds burden to the administrator, to the owners of those credentials and applications. So if they are not rotated in time, they end up being long-lived, and if they're shared, you end up in that same place where you're increasing your risk of a breach because you have potential exposure of these long-lived credentials, right? So what's the solution? So I mentioned earlier, Vault has a bunch of different secrets engines that can do a lot of really great advanced capabilities. One of those capabilities is to generate dynamic secrets, dynamic credentials. And the key idea here is that these credentials are generated just in time only when needed versus having static credentials that you're manually having to actively rotate, and they may or may not be used, but you have to rotate them anyways. Whereas now you're letting Vault manage the whole secrets lifecycle management of these credentials to generate only when needed and automatically expire within a short window. So if it is shared, then it's pretty much useless to anyone outside of that window, right? So you can also do on-demand revocation of those credentials as well. And there's broad support for these secrets, dynamic secrets as well. You can generate for them for SSH servers, for all sorts of IAM credentials, for databases, right? So really wide support to generate these dynamic secrets. So no reason for you not to use them versus the kind of the way that's typically done with manually rotating them. Okay, so now that we've, again, moved along that journey from unmanaged to now managed to actually securing your credentials with dynamic secrets, how can we further reduce that risk and really make it easy for users to consume these credentials when they're trying to access your infrastructure resources? So let's take a look at how Boundary can step in and integrate with Vault and really help with that whole process. And to illustrate this, what I have is some diagrams here, and we'll kind of show a before and after of what things look like when you are not using Boundary, and then what things look like when you are using Boundary. So we'll use an example that's very common, which is a VPN or some sort of jump host, but let's just say VPN for this, this example here. The user logs into the VPN. That's step number one, right? So the login is pretty straightforward. It's not that hard to log in using a VPN, but then the challenge is that now that user, they can pretty much go laterally anywhere in that network, whether they're permitted to or not. They can maybe they have the capability to log into those systems, maybe they don't, but they're still on that entire network, right? So that's one security concern. You're not enforcing least privilege access. So the next concern is that the workflow now includes the fact that they have to look up the IP addresses of these resources, right? Of course, resources are ephemeral. IPs are ephemeral all the time, so it's very challenging for them to keep track of the IP address. So they have to go and look it up in some spreadsheet or some other console, some other tool. Either way, it's an extra step. And then the third step is to retrieve those credentials. And in this case, we're assuming you're using Vault. So in terms of credentials, you're fine, but you still have to take that step to grab the credentials for the specific system you're looking to access, right? So we're at the 3 steps, and then finally you grab those credentials and you log onto your system. Let's say you're using SSH and logging onto an SSH server to get onto a Linux system. Right? So roughly 4 or 5 steps depending on your situation. So now let's take a look at what it looks like when you use Boundary and how Boundary can help streamline it and make it more secure. So they log on, the user logs on to Boundary, a one-time thing, right? And once they're logged on, well, actually before they log on, Boundary can integrate with other identity providers using OIDC or LDAP. So now it's single sign-on to Okta or Entra ID or Ping or whatever supports those OIDC or LDAP protocols. Once they're logged on, Boundary identifies that person. Boundary knows that identity, and there's a pre-assigned or pre-authorized list of systems that that user is allowed to talk to. So now you're enforcing least privilege access, right? And the user doesn't even have to know about the IP address or where it's located. Boundary will take care of all that. The user just says, okay, I get a list of systems I'm allowed to connect to. Let's say I want to connect to this Linux host over here. So they select it. So that's step number 2. And once they select it, what Boundary will do is on behalf of the user, it'll go out to Vault and grab the credentials for that user for that specific system and then present it back to the user. Right? And then finally, step number 3, the user does the connection using that the credential, they log on to their system. Again, let's say they're using an SSH terminal, they go in there, they log in and provide the credentials. Right? So you're reducing it down to roughly 3 steps. How can we make this more streamlined and also more secure? Well, we have something called credential injection. So with credential injection, let's go through the steps one more time. Same thing, user logs on. They're limited to what system they can access. They select the system that they want to access. In this case, again, that same Linux host. And Boundary, again, goes out and retrieves the credential on behalf of the user. But instead of giving it back to the user, what it does is it'll inject that directly into that target. So now it's more streamlined because the user doesn't need to handle the credentials. They don't need to enter the credentials at all. It's completely passwordless, right? And it's more secure as well. The user never even sees it, and they don't have that opportunity to even share it with someone else or accidentally leak it at all. And on top of that, it's dynamic credentials from Vault, so it's also short-lived. So we're taking multiple angles at really reducing that risk and really minimizing, and at this point, eliminating any risk of exposure, right? So we went down to what, 2 steps? So now I want to introduce a new feature that we are working on. It's right now going through beta phase, and it's called Transparent Session. So we are always striving to make things easier for the end users to be able to use our products, especially for for Boundary, and to be able to adopt it, and make it as streamlined as possible. And with transparent proxy, the idea is not just to make it easy, but we want it to make it invisible, so that the user doesn't even need to click any buttons or have any type of interaction with Boundary. Things just happen in the background magically, so that the user just goes in and does their normal workflow. And so what does that look like? So again, we'll go through the same steps. The user logs on, right, onto Boundary, and that's it. At this point, all they have to do is just use their normal tools again, right? They don't know Boundary exists except for the logon part. They don't have to click on anything to connect, to tell Boundary to connect them. They don't have to run any other commands that are related to Boundary. They just go to their typical client, whether that's PuTTY or RDP client, or in this case, an SSH terminal, and just type in SSH and their host name. No credentials are needed in this case for SSH, because we're using credential injection. So in the background, Boundary will recognize that. It'll grab the credential from Vault and also inject it into the system, into the target system on behalf of the user, and the user's in. Right, so they just directly logged on without even knowing that Boundary was even there besides the part of when they logged on. Right, so that's Transparent Session. That's now in private beta, and we're targeting for that release later this year. So life goes on, right? The user logs off. They're done with their session, but life goes on in terms of lifecycle management for these sessions from a Boundary point of view. So we have something called session recording. Session recording is there for various reasons, one being compliance. Sometimes audit logs are not good enough. Audit logs provide information on when a user logged onto which system, but it doesn't give them information on what they actually did when they've logged onto a session, like an SSH session. So SSH session recording provides that insight into understanding what they did, right? So if there was some type of a breach, the administrators, security folks can analyze, go into the session recording, understand, hey, they logged on, they moved around to different directories, they downloaded things, they uploaded things, they deleted things. What exactly did they do? So then, at that point, you can make an informative plan to remediate any type of potential breaches. On top of that, there's also the preventative nature of it as well. as a deterrent, when users know that they're being recorded, they're a lot less likely to perform anything that is, frowned upon within their organization, right? So there's multiple benefits from session recording here. So now we're going to go through a quick demo to kind of wrap up all those different things that we just spoke about. All right, so if you're not familiar with this, this is the HCP dashboard. Once you log on, you see all the different products that is available on HCP. I'm going to click on Vault Radar. So as I click on Vault Radar, I'm going to be taken to my Vault Radar dashboard. I get a bunch of information, a bunch of really pretty graphs, but just things that tell me that my attention is needed, right? And various ways to visualize and bucketize the different categories and different detection that was made. There are also integrations. So if I click on settings here, you'll see the various integration points that I mentioned earlier, including Slack, where you can go in this case, we've connected the 2 points where Vault Radar is connected to our Slack, and so that if something happens, there can be a notification for the administrator. So what does that look like in terms of a notification? Well, you see a pop-up like this here for the administrator, and then if they go to that Slack message itself, if they go into their channel, they'll see that, hey, an alert indeed did happen. There's some high-level information of that detection. There's a link that takes that user or that person back into Vault Radar with context on this detection, the severity of it, the type of credential that was identified, and also a link to that data source where that credential was detected. In this case, if I click on it, it takes me directly into my GitHub repo, and indeed there is an SSH key that was stored here, right? So that's just a quick use case, a quick example of Vault Radar. So now we're moving on to the next part, which is remediation and storing that credential onto Vault instead of this unmanaged GitHub repo. So now let's go back to HCP, and we'll go to the overview, and then we'll click on my Vault instance, my Vault cluster. All right, so let's go back to the dashboard here. So I'm on my Vault cluster, and let's go to the Vault UI. So click on the cluster. I'm still on HCP, but I'll click on the cluster UI right now. And so now we're into the Vault cluster admin UI. And you'll see the different secrets engines that I've already enabled. One in particular is just the KV secrets engine, the very simple secrets engine where you can store static credentials. And in this case, I have an SSH key where I can click on it and you can see that, hey, you should always store your credentials on Vault, and this is one example of using the KV engine instead of in GitHub repo. So the other option, right, we're now maturing more, and instead of using the KV secrets engine, let's take a look at the SSH secrets engine that allows you to create dynamic credentials for SSH targets. So I have the SSH engine enabled there. Now I'm going on to Boundary to point Boundary at my SSH secrets engine on Vault. So in my Boundary UI, I'll go into the credential store, and here's my URL for my Vault instance. So it's really basically pointing at Vault. And then in the credential library, it's pointing at that specific secrets engine inside of Vault. So now we're just connecting the two pieces, connecting Vault to Boundary. And also, when I go to my target itself, which in this case is a Linux host, I'm telling it to do credential injection, but pull those credentials from that secrets engine, from that SSH secrets engine that lives inside of Vault. So now, tying that all together from the user's point of view, they don't need to know about any of that other stuff. They log in. In this case, I'm using username password, but they can use any identity provider, like I mentioned. So they're logging on, right? And this is really an example of transparent session. They logged on, and that was it. They get a list of systems they're allowed to connect to, no IP addresses that they need to care about, and all they do is go to their terminal, whatever the client is that they want to connect to, or that they want to use, and type it in, and now they're on. Passwordless experience, and now they're on. And then they start doing whatever they want, as a developer. And so now the session ends. As I mentioned, life goes on, right? From the Boundary point of view, as an admin, all those sessions are recorded And so if I go in as an admin, I can click on all the different sessions throughout the history of Boundary and click play, and you see everything that just happened 10, 15 seconds ago. And as an admin, I can see and have better insights, have better compliance as well. All right? Okay, so let's go back out to one last part. This is the end of my demo. Let's go back to my slides real quick. So one parting slide is that if you want to get more information, we have lots of really great resources on our website, from tutorials to ways to get certified with our various different products. From an HCP standpoint, you can sign up for free, get credits, start using it right away. And if you're interested in the developments on Boundary and some of the things coming out with transparent sessions, go ahead and grab a screenshot of these QRs or the links itself, and then we'll be able to communicate with you down the road. And with that, I think my session's ending. Thank you very much for your time.